Hello everyone and welcome to this next edition of the ADVI Connect series where we're going to meet the leading testbed operators around Australia. And we've got quite a comprehensive on-road and off-road testbed group of organisations for you to hear from today. My name is Rita Excel and I'm the Executive Director of the Australia and New Zealand Driverless Vehicle Initiative. We are a collaboration of over 150 partners who've got a common vision to see this technology introduced into Australia and New Zealand as efficiently and safely as possible. So today we're going to be looking at and hearing from some leading testbed operators on and off-road testbeds. And a lot of these are connected testbeds because we see connected vehicles as a key pillar to introducing ahead of fully driverless technology. So the format we'll have is we'll hear from our two on-road connected vehicle testbeds experts, Professor Majid Sabi and Tam Mccaffrey, and then we'll move off-road. We'll hear about the Crash Lab and also the Cadet Facility, and then the Collie Test Facility in Western Australia. We'll also hear from our presenters and then we'll take questions. So please, in a traditional format, please put your questions and to who you think you want to direct that question to. If you're not fast and you've just got a general question, just leave it as a general question. The session will take about an hour and we're going to be running some videos and slides for your information, and then subject to approval from our presenters, we'll be able to share them with you. This will be recorded, so you'll be able to access it later on as well. So without further ado, I'd like to introduce you to Tam Mccaffrey, who runs the City project in Wollongong in New South Wales. So Tam, over to you if you want to tell us a bit about your initiative and what's been going on there and what's proposed to happen. So thanks, Tam.
Thank you, Rita. Thank you for allowing me to speak about this important initiative that we're delivering on behalf of the New South Wales Government, our City project. This is a great forum to be able to do this and talk about some of the innovative work that we're doing, and also share with some of our other colleagues throughout the country to hear the latest and greatest. So Susie, if you just go to the next slide for me, please. Thank you, Susie. I'll just have a short video to play which will give everybody a bit of a high level introduction to City. So if you just play that video, please, Susie. Thank you, Susie. If you could just go to the next slide when you're ready. So yeah, I hope that's given everybody a bit of a high-level overview of the city program and what we're doing in New South Wales in that space. The video has been superseded to some degree, so there's been some changes in that space where we talk about we're constantly improving, and we have in that area. So we talked about it's located in the city of Wollongong, which is 90 kilometres south of Sydney. We're now up to around 21,500 kilometres of road network coverage. The video refers to a smaller amount, but since that time we have expanded the footprint of the network. We have an Australian Communications and Media Authority scientific licence to conduct, ITS-based licence to conduct our trial. We broadcast on the 5.9 gigahertz spectrum via DSRC, and for those that aren't familiar with that terminology, it means digital short-range communications. And we're also fully equipped to the European standard with our infrastructure. We did start off at the American standard some years ago, but we've been progressively refreshing that and converting over to European standards. So if you just go to the next video, Susie, or next slide rather. So just a bit of a highlight there, an overview of the video again. At various parts of the trial, the city program, we've had up to 60 heavy vehicles, 11 buses. We're now up to 7 connected intersections where the video referred to 3. We have 1 level crossing, and we're actually progressing that to another level crossing, which I'll talk about later in the presentation. We have four portable roadside units. One's located at a heavy vehicle rest station, and we have 3 other portables. We've had up to 50 light vehicles at different phases through the project. Even had a motorcycle, connected motorcycle, which was quite interesting at one phase. And as I mentioned, a connected rest area on Mount Ousley Road, which services our transient heavy vehicle drivers and other people as well, so towing caravans and whatnot, just as a safe area to rest on their journeys. So if we just go to the next slide, thanks. I don't want to get too technical with everyone. I'm not sure what the audience is. I've been caught with this before. So I'll just talk. We've just got some pictures here about some of our technology. It's fairly straightforward. We've fitted our connected vehicles out with a display, so obviously drivers can see the connection and interact with the system. And there's substantial equipment relating to the Coda wireless system, antennas and whatnot for our DSRC. On the right of the presentation, there's our telematics kit, which there's a bit of a trick of that in positioning, particularly the accelerometer. So that has to be positioned quite central in the vehicle so we get accurate acceleration readings, which all feeds into the data we're capturing for our to enable us to provide accurate insights into the research outcomes of the project. Just go to the next slide, please, Susie. So current warnings, we have 2 classes of warnings: vehicle to vehicle and vehicle to infrastructure. In terms of vehicle to vehicle, we have an intersection collision warning, which alluded to on the video, and also harsh braking ahead. And in the vehicle to infrastructure warnings, we have a 40-kilometre speed limit warning, which is really important for us because the downhill descent from the coast or from the mountains into the coastal area of Wollongong is quite steep. It's a well-known truck route, so we're actually able to provide the connected vehicles, heavy vehicles, an alert that they're travelling in a 40-kilometre-hour zone, and hopefully that will assist their behaviour and driving down Mount Ousley. And also 2 other warnings: red light ahead, and also level crossing warning, which I'll get into a little bit more detail as we go along. So next slide, please. Heavy vehicle operations, I think this is an important element I'd like to talk about. As you can see there, it's quite a well-used heavy vehicle route. So from the Hume Highway, if people are familiar with New South Wales, or if you're not, I'll try and draw a picture. New South Wales, we have the Hume Highway, which traverses between Sydney and Melbourne. And basically, we take a spur off that along Picton Road. So from Picton Road, Hume Highway to Picton Road, that takes us down to the ports area in Wollongong. So for our research purposes, it's very interesting because we've got regular heavy vehicle usage, and some of the companies that we're using obviously traverse that route, so that's important for our research purposes. As I said there, Picton Road's a major freight artery linking the inland parts of the New South Wales to the coast. And Port Kembla is very much a key infrastructure asset in New South Wales. We also have the state's largest motor vehicle import hub, located in the area, and also grain terminals and large active steelworks in the area. So as you can see, there's a lot of reasons for heavy vehicles to traverse and come into Wollongong for just to do business as usual. So next slide, please. I talked before about an additional road rail level crossing. In the city project, we're really excited about this because this is definitely an area we've been looking to gain more insights on. We currently have a connected level crossing in what you would call in the port area, which is more of a limited access. And we've used that as a proof of concept for, as I said, proving the technology works, and it does. And now we're in the active process of going out into the real road network. So we're going to a location which is the second busiest crossing in New South Wales with train crossings and actuations. There is a history of road safety issues at the location, and the exciting thing for us is that now we're going to we've proved the concept. Now we're going to apply that technology in the real world with all sorts of vehicle classes going along there, cars, heavy vehicles, predominantly buses, and we're really interested to see what sort of learnings we're going to get out of that and how the drivers interact when they see the level crossing change of status. So if you just go to the next slide, please. So some of the advantages of our test bed. It's a safe, mature and well-maintained test bed. So we've been in operation since 2014. So we're moving through different phases of projects and obviously continuously improving and upgrading our infrastructure. It's home to Port Kembla, which I talked about before, which is a major attraction, particularly for the heavy vehicle clientele that we have. One of the great things about Wollongong is that there's a lot less congestion than there is on the Sydney road network. So in our opinion, conducting trials in the Wollongong area is a lot safer. You're still going to get the same classification and classes of vehicles, but you don't have the obviously congestion problems and those sorts of restraints that you have in the Sydney, greater Sydney area. And as I said before, it's a reasonably big test bed in some ways, but small in others. But we have the capability there to conduct small scale trials and particularly and research. And as I said before, we have the right blend of freight task and the size of the road network. So let's go to the next slide, please. We do collaborate across government to New South Wales government and outside of government to deliver this project. You can see some of our partners there. We're currently working closely with Sydney Trains and Pacific National regarding the integration of the new connected crossing at Untitled into the test bed. And we've done ARB and Austroads have done some great work for us in New South Wales in terms of helping us with various phases of the project, subject matter expertise, and it's been really, really important to the various phases of the project. And last but not least, just calling out some of our local suppliers, Bucklands, who've done some great auto electrical work and vehicle maintenance for our connected fleet. Just go to the next slide, please. Bearing in mind time. And I'd just like to share with everyone a little area that we're starting to work into at the moment to evaluate. Basically, we're looking at improving our accuracy for our city fleet. It's quite innovative in that we're connecting into an existing connected surveying network where surveyors use to do their thing, shoot their measurements around and connect and measure. So in New South Wales, we have a measuring stations in our test bed. So we've been able to actually interface our city system in with that test bed. And we're starting to see some really interesting improvements in terms of location, being able to locate vehicles rather. Basically getting down without using this technology, it was down to about 160 centimetres. With this technology, we're starting to understand we can get down to less than 3 centimetres. So that's really exciting because like all testbed operators and anyone using GPS, you want to have full confidence about what you're looking at, where it is in relation to the road network. So that we're still actually be working to that at the moment, and it's looking really promising. So we're continuing to progress some of these niche business cases to get more out of the test bed. So this last slide. So pretty much that's it from me. We're always looking for input from our community. We'd love more heavy vehicles in our trial, and we can be contacted. I can be contacted either via Rita or ADVI, or I've got some details that I'm happy to forward to anyone else if they would like. So once again, thank you for allowing me to present to the community, and I'm looking forward to the next presentations. Thank you.
Thanks, Tam. Thanks very much for that. And Mount Ousley is infamous, obviously, for that steep descent and that amount of heavy vehicles. So that's great to hear about the project. And then the next stages, and obviously railway level crossings are one of those safety issues as well. So, and heavy vehicles and railway level crossings really important for our the way we move freight and goods around Australia. So thank you for that. So we will take questions at the end, but now I want to move on to Professor Majid Savi, who runs the AIMS testbed, so right in the centre of the Melbourne CBD. And over to you, Professor Majid Savi.
Thank you, Rita. Thank you for this opportunity. Really appreciate it. I apologize for some background noise, some heavy gardening happening around my house because we're in lockdown, so apparently we can do more than that. Apology for that. So I put few slides together, not really presenting what exactly AIM is doing because we have lots of material online available. You can have a look. I pretty much give you some background about what we have been doing since 2016. So if you please go to the next slide. So this is if you're familiar with Melbourne, this is pretty much the central part of AIMS. Melbourne University is located basically next to this area and is adjacent to the Melbourne CBD. It has about 70 intersections and is about 100 kilometers of road network. And we have now over 250 devices from different sorts, from DSRC to Wi-Fi, Bluetooth, environmental sensors, different type of cameras, different devices like HVAC computing, etc., etc. I think that the philosophy behind them is we're looking at a system. We're not really interested in addressing particular mode or particular sort of challenge that you would like to address. We're pretty much trying to be the smartphone of a transport system. So if you have a transport system which is connected and also is able to basically communicate different sort of data that you like, then the smart people come and build thousands of applications hopefully. So as AIMS, we focus on functionality rather than particular challenges, even if we we have carried out several projects in the past. But the whole idea of AIMS is if you have an ecosystem, if you have connectivity between different modes, if you can retrofit the existing infrastructure to become better, smarter, then what are the potential solution you can bring in. So that was the sort of philosophy behind AIMS as an ecosystem. So if you please go to the next slide, why we decided about this area. I think this is a perfect storm. If again you're familiar with Melbourne, in this area we have a significant amount of cycling and walking to work. So we have active mode, we have people using e-scooters, we have heavy city logistic, we have massive freight movement from east to west and vice versa is a significant corridor. We have trams and also we have lots of buses moving around. So it's a very complex environment. We have very legacy system as a SCAT. So what we're going to do with that, when you put different type of sensors that they're delivering different sort of outcomes. So how could you bring them all together in order to be able to look at the transport system you would like to have in future? So connectivity and automation, all of this is in our horizon. But at the same time, we would like to apply some of the finding that can address some of the challenges that we have today, such as how you could look at one intersection and provide, for example, priority to public transport. At the same time, you'll be able to improve the safety for people walking or cycling at that intersection. So that was the sort of challenge we put for ourselves. from the first day, and using the real world environment, so you can learn as you go forward. If you can go please to the next slide. So this is a sort of a list of our partners. Is not to impress people, basically to show how complex it is to work in a ecosystem. Some people call it a smart city. So you need to have the right partners. We partner with the government very closely. So we have founding member, indeed, Vicro Department of Transport, Cubic as our founding member, and WSP, and then we have others such as those that provide technology like Q-Free, CAPS, Coda, Wireless, etc. We have telecom companies like Telstra and so on and so forth, and then we have transport operator, Transurban, or Yaratram, and then we also have tech company like AWS, Cisco, etc. Insurance like IAG. So it's basically an ecosystem. Everybody come from different angle, and that's the beauty of it. So we don't have anybody that is really leading this in a significant way. It's a collaborative joint venture where government has the same amount of power that everybody else has, and I think that's a good thing. So give a good balance to applied research at that sort of level. We're also very supportive of a startup and small companies that they would like to using the data come out of ecosystem and do great stuff. So if you please go to the next slide, I just put a few slides about technology that we installed on infrastructure. If anybody has done anything in a city, these are challenging because you need to find the right infrastructure, and if you want to do one or two is a simple thing. For example, at the moment we have close to 50 connected intersections, but if you want to do it in a scale, then you start to realize how difficult it is to do it at a scale in terms of issues that you need to go through it. And I think that's one of the beauty of this type of project. If we go please to the next slide, we also have some connected vehicle, not as sort of as many as Tam was talking about, because we wanted to have just few, and hoping that connected vehicle coming from the new cars coming to the ecosystem. So we again focus more or less on the infrastructure side, on the data side. And we didn't equip as many as vehicle as been in New South Wales, but hopefully that more coming. So these are some of the heavy trucks from Woodward's that we equipped with the DSR system, similar as what Tam was explaining. If we go please to the next slide, we also we have an autonomous bus. EasyMile is one of our partners. So this is not for providing any particular service; it's totally for research. So we can, for example, program the bus in the way we want, adding sensors. For example, we did some work together with Cisco and EasyMile and Coda Wireless, putting devices to this bus to be able to navigate through a signalized intersection. So it's pretty much for research. It's not for providing any service. If you go please to the next slide, we also this is one of the intersection. We have over 40 components fit to this intersection to provide very sort of smart intersection. We have, I think, lots of cameras and computers in this system working together, and I think Cisco was one of the leading partners in this project. And as I mentioned, for example, the challenge here was if you have a bicycle going straight and a truck turning left, can you pick it up? Can you do something about it? If you can do something about it, can you do it for 50 intersection, 100 intersection? So learning what can be done if you want to put significant amount of technology to uplift, the capability of, your signal system. At the same time, we can do it in a scalable level. In Melbourne, we have 4,000 intersections. So we're talking about a huge number. And I think if you're interested, our last slide is just giving you some web address about what can be done, and you can get a lot of information from our webpage. Thank you very much, and over to the next presenter.
Thank you, Majid. That's really great, and congratulations on such a great facility, and looking at it from a research but also collaboration perspective. So we definitely have some questions for you following that presentation. So now we're moving from on-road to off-road, and Alex Lay is going to present on two facilities that he operates. One is a laboratory called Crash Lab, and the other one is an on-road test bed at Cadet. So over to you, Alex.
Thank you, Rita. Welcome everyone, and thank you for having me. Today, what I'm going to do is just showcase some testing capabilities that we have at both our Huntingwood and Cadet facilities. I'll start with the Huntingwood site at Blacktown for now, and I'll move on to the Cadet one a bit later. Next slide, please. Just a quick overview. Crash Lab is the only government-owned facility of its kind in Australia. Currently, both Huntingwood and the Cadet facilities falls into this category. We provide research and technical support for the development of road safety policy and regulation, primarily for Transport for New South Wales, but also across the entire road network. We also deliver on NETI consumer information rating systems such as ANCAP, CREP, Crash, and MotorCap. We've been operating here for well over 25 years in this space, so we've got a very big practical knowledge and expertise in the evaluation of vehicle occupant and road user safety equipment and crash worthiness of roadside furniture products. Next slide, please. Just a quick few slides about the Huntingwood facility. We've got a fully enclosed runway, about 180 meters long, which also extends out to another outdoor area, which we'll see in the next slide, please. This area goes for another 200 meters, 100 meter wide. This is where we conduct a lot of our outdoor testing, whether it be roadside products or other infrastructure testing. Next slide, please. The crash barrier itself is a world-class facility. We've got, you can see it in the left picture, a 105-ton movable block, which picks itself up and walks across the track to suit a wide range of testing. We've got a pit as well, which can be utilized for underbody cameras and inspections. But all that can also be replaced out with a solid floor, just depending on the application. So by moving that block out of the way, we can then utilize the entire indoor runway and extend it out to the outdoor section as well for various tests. Next slide, please. It's just a quick picture of our vehicle preparation bays that we use to prepare the test vehicles for various tests. Next slide. We have a fully equipped workshop fabrication area. We've got a list of qualified staff who are on hand ready to make up support any fixtures we may need to fabricate for any research or one-off projects that we quite often get here as well. And the team here are very, very capable and well equipped in making all sorts of adaptations to satisfy testing needs. Next. One of the key areas in the Crash Lab facility is the vehicle measurement room. It is a 24-hour conditioned room. The reason for this is to maintain a conditioned environment so that test vehicles and in particular test dummies are soaked in an environment to maintain a stable condition. Part of this is also we test to international protocols, and it is expected that the conditions that we're testing to are repeatable and comparable to overseas labs. As you can imagine, Australia has quite different environments to the rest of the world, and the only way we can make sure that our data and results are transparent is to make sure that the testing environment is also consistent throughout the test labs. We have vehicle measurement systems such as the SimCore and the Faro, which is a very high sophisticated 3D measurement machines. We use to measure vehicle deformation, dummy positions, which is all very critical in the analysis of test results. Next, please. In terms of data acquisition, over the years, you can see the development of technology on the left there. The scale is not quite right, but the mini dowels on the left there, they're of decent size. They generally need to be mounted into the back of the vehicle or somewhere suitable. But over time, we're slowly moving towards onboard DAS equipment. So as you can see there, a good illustration of that dummy holding what they call the slice. Basically, that has replaced what you see on the left there. So it's become very sophisticated and very adaptable. Next slide, please. This is the ADVI calibration. So ADVI stands for anthropomorphic test devices, or more commonly known as just dummies, test dummies. All those rigs on the left there are necessary to calibrate and maintain calibration of our dummy family, which we now have a very comprehensive number of. So our latest acquisition was a 4 dummy. From memory, I think it was well over $1.4 million to acquire that test dummy. And these are things that we need to invest in to make sure that we stay on top in this testing space and be able to meet particular changing test protocols and requirements. Again, the purpose of calibrating test dummies is to maintain and ensure that the values obtained during testing are consistent and can be traced and have traceability to make sure that it's valid and comparable to test labs overseas as well. Next slide, please. The crash lab itself, I think most people only consider us as crashing vehicles, but we actually do a lot of other work at Crash Lab. We have a helmet laboratory, which up until recently was used to not only do batch testing for manufacturers, but also test helmets to Australian standards, to make sure that they pass our very stringent standards. But we also use it now a lot of research work, recent projects involving attachments to helmets or misuse of helmets is an example of what we do here. Next slide, please. We also have a sled laboratory. Now, what you can see there is a rebound sled. Now, my understanding is it's the only rebound sled in the Southern Hemisphere. It is also the sled responsible for the initial development of the Australian standards, or part of that process to establish the Australian standards in terms of child restraint testing. And that sled is very versatile. As you can see there, we not that long ago worked with one of our partners to test integrated child booster seats in various models of vehicles to see how it compares to using it with and without external child restraint systems. So lot of different tests that we can do in the lab and at Crash Lab. Next slide, please. The harness drop tower is another part of Crash Lab. Industrial harnesses, not really a big part of our operation anymore, but still a capability that we have that we can use if ever needed. So, next slide. So the next few slides will just be pictures of tests, different tests that we do here at Crash Lab. I won't go through them in detail, but you can see we do a very broad spectrum of testing here. Our main focus is predominantly road safety, but we also collaborate with defence to make sure that our troops are safe in their armoured vehicles and the occupant injuries if they when they are under attack or landmines, for example. Some of the pictures you can see down the bottom there are research tests that we've done, you know, driving passengers without a seatbelt, carrying infants in the front seat, putting your feet on the dash. All these initiatives are part of our vision to try and reduce road tolls and in line with road safety initiatives. Next slide, please. Again, this is a little bit about crash lab and the outdoor areas. We've conducted rollover testing. We get some weird and funny jobs come through every now and then. For example, the go-kart you can see there. It's again a project that we took on. I suppose customers were getting injured in go-kart crashes. It was becoming an insurance issue and all sorts of other liabilities. So we were engaged to demonstrate and try and see how we could help improve that space. So yeah, there's a lot of weird and wonderful things we do here, which always keeps us very busy. Next slide. I might just skip this one again. It's just a roadside furniture testing that we do at the back. We've worked for with security to develop anti-terrorism products, which is what you can see down the bottom there, and also for the motorcycle community in terms of hitting guardrail and developing products to protect riders when they do fall off their bikes. Next, please. This clip here is you can play that when you're ready. It's just a head-to-head test that we were asked to conduct. The main purpose of this is just for consumer information. Message is, you know, when you're buying a used car, whether it be for yourself or for your children, try and choose the safest car possible and affordable. This is demonstrating a 5-star vehicle versus a 2-star vehicle when rated against the used car safety rating. But again, this just showcases capabilities that we can do here. If you remember earlier that slide with that block, I said they can move out of the way. Well, that's how you achieve that. You actually move that block right out of the track, the center of the track, and these two vehicles are pulled in on an offset and they collide just over that glass pit that you also saw earlier on. Next. As part of road safety research that we do here, this is a test that we conducted, and this is what happens when you decide not to wear a seatbelt. So these are all very good educational tools. I believe picture paints 1,000 words. A lot of people think seatbelts not that important. We're only just going down the road. We'll be right. Well, no, you won't be, as you can see from there. Next, please. This one was quite fun. This is a colleague of mine were asked to develop some testing to sort of provide some scientific data and some visual evidence relating to the recent legislation that got passed. Well, not quite recent now, but the whole maintaining a safe distance between cyclists. So we had to design a rig and a method to demonstrate. I'll play the video again. Just to demonstrate what happens when you drive too closely to a cyclist, and if you were to accidentally clip them, and from this, policy decisions are made with the help of such testing. And I think it is now you need to be a metre away from a cyclist, depending on what speed you're doing, or 1.5 meters. Yeah, so again, very challenging work we do here, but always a lot of fun. So. Next slide, please. I might skip this one. This one pretty much explains itself. Wire rope development. So it's part of our roadside furniture testing capabilities here at Crash Lab. I guess what they mean by unforgiving is if that, yep, sorry, no, okay, we can move on, that's fine. So this is what I was talking about before in terms of motorcycle riders when they fall off the bike. typically Armco don't have that wobbly bit. You can see down bottom there. That's commonly referred to as MPS, or motorcycle protection systems. We were part of a program to develop an efficient method to do this. If that wasn't there, there was chance of the dummy's head, the rider's head, could hit one of the posts, which was not ideal. But by having this inclusion, you can see it redirects away from the barrier. So next, please. Part of anti-terrorism, I think we were just looking at, it was just off the back of a lot of unwanted activities around the world a couple of years ago. So we looked into what is the cheapest and most effective options that we could deploy if there was, say, some sort of an event, public event. Well, we've got a bunch of buses and trucks and things that we can just roll out, I guess, and it could act as a temporary barrier. Again, these are all just research ideas that we helped collaborate with and gave them options if ever need be. So thankfully we haven't had to deploy any of this stuff in recent times, but I think it's always good to have that capability. Next, please. Okay, so moving on to the Cadet Facility. So the Cadet Facility was acquired over 2 years ago. We've been in operation since last October, around October. And on the 28th of October last year, we actually conducted Australia's very first and official ANCAP safety assist testing on a test vehicle. Cadet was located about 40 minutes from Orange, out in western region of New South Wales. We can go to the next slide. That's a video show. We can play that video. The runway itself is a 1.5 kilometre long runway. It's an disused airport, which once upon a time ANZAC ran through there before they went belly up, and then Hazelton was also running out of there regionally as well. So as you can see there, it's just a few bits of equipment that we have acquired and we use to conduct some ANCAP testing. This equipment isn't specifically for ANCAP, but it's what we've been doing in the last few months. You've got adults, children, cyclists. The idea is obviously to demonstrate vehicle technologies in this space, autonomous stopping, AEB, detecting objects, and ensuring that there's no impact when it sees it. So next slide. On the left there is commonly known as a GST or a GVT, which is a global soft target. It's basically a foam car, if you want to put it that way, sitting on a very sophisticated platform, which is robot controlled and guided by GPS. The idea is to have test vehicles following this vehicle, and if the GVT comes to a stop, for argument's sake, you want the test vehicle to pull up and not hit it. But if you do hit it, it'll just blow it up and you just reassemble it. So very, very expensive and sophisticated equipment, but necessary in achieving road safety objectives. Next, please. And that's just a breakdown of the GST that you saw earlier on. On the right there is just the steering robots, braking robots, accelerator robots that are typically need to be installed in a test vehicle. There is always a driver in the vehicle just for assurance, safety assurance, but technically the robots drive the vehicle on a defined path and is very repeatable in all the cases. Next. This video here is of official ANCAP testing that was recently completed, which also saw Isuzu D-Max get awarded with the highest ANCAP rating of 5 stars. I believe it was the very first commercial ute in Australia to be awarded 5 stars in this space. So it was a very good achievement for both Isuzu and for Crash Lab to be able to be part of this. Next. That test there again was just a car into following another vehicle. As you did see, it stopped. So this one would be a vehicle approaching a pedestrian. It's a bit glitchy. Sorry about that. But so as you can see, the cyclist just decides to cross the road, and the vehicle stopped without impacting it. Similarly here, an adult crossing the road, and again the vehicle stopped. It looks like the videos aren't buffering too well on my end anyway, so I do apologise, but I think everybody gets the picture. Just trying to demonstrate the facility and the equipment. So we can move on from that. I'm just mindful of time as well. Sorry. Again, just another scenario, a child ducking out in front of a couple of parked cars, which happens a lot more often than we'd like, I think. So again, the vehicle pulled up, did not impact the child. One of the trickier tests to pass, this one. And of course, there's a nighttime component as well, both with street lights and without street lights. This one here, it makes it a lot more challenging at night, obviously, vehicles, radar systems and camera systems, but this vehicle managed to pass quite easily. So this one is a scenario where you're trying to change lanes, and there's a vehicle coming up on your side, blind spot as such. The vehicle's ability using blind spot monitoring to detect the vehicle coming and correct itself and not turn into that. So this is all possible through the using GPS and the robots on the car, but relying on the vehicle's actual technology to actually perform this way. So, and that is what we are assessing. Next slide, please. So yeah, like I said, I try to keep this casual. I don't want to get too technical and carry on about too much of the background, but I just want to showcase the testing capabilities of both Huntingwood and Cadet. I'm sure there'll be a lot more questions, but if you do have any, reach out to Rita and she'll be able to put you in contact with me. So thank you for your time and I hope you enjoyed it.
Thanks, Alex. That was really comprehensive and covering 2 facilities. So well done to you. And definitely we can't set standards if we don't actually test to them, and then we can't develop new standards unless we understand that. So it's great to hear that is happening and the world-class tests that you carry out in Australia. So last but not least, we're heading over to the west. David White is going to tell us about one of the newest facilities, the WestTrack Technology Training Centre. So over to you, David.
Yeah, thanks very much, Rita, and thanks for the opportunity to dial in today and give everyone an update on what we're doing. So there's a quick video at the start of this presentation, I think, Rita, if we can watch that, and then I will elaborate after that.
The WestTrack Technology Training Centre is an absolutely unique facility. It is the only Caterpillar autonomous training facility outside of North America.
Kids from today are good with technology, aren't you? You probably operate from your iPad, hey?
Yeah.
You drive that with your iPad?
Maybe.
I expect that the next couple of years we'll see a rapid growth here where we accommodate more than trucks, more than shovels, where we get to a whole of mine solution being taught here.
this training facility right here in Collie is able to be used by locals and people across the state alike. It's one of those projects that will secure the long-term future of a great town.
We are hoping we will be able to expand this facility as we see further technologies advancements in the resources sector. This ensures we not only grow the skills for today, but also the skills for the future. And at WesTrac, we're really proud of the history we've had in training many people here in the state.
So yeah, if we can head to the second slide along, thanks Rita. I suppose we started, to give a quick overview of WesTrac. So in WA, we have a very large area that we cover. We've got just over 2,000 employees. We're based out of South Guildford, and we have 10 branches around Western Australia, as well as we have basically mini branches as far as on-site operations at some of our clients' mine sites. We have residential technicians all around the state, and it's all based around the support network required to be able to support, I suppose, what is the very diverse nature of mining within WA. We've got over 120 specially kitted out vehicles that roam the state, or very specifically set out for different areas to be able to service our client sites. If you can go to the next slide, thanks, Rita. And so from an autonomous point of view, and to paint a bit of a picture, so we have at the moment, or we've just clicked over 305 autonomous haul trucks in Western Australia. It's a significant amount of haul trucks have been converted to autonomous, and the majority of those are 793 size, so 240 tonne class haul trucks. We have some that are actually larger on ultra class and a few on smaller 7, 8, 9 cat equipment. So we've implemented, we're the biggest user of autonomous in the world in Western Australia. The thing, I suppose, and why the Collie facility came about was that we have the lion's share of autonomous vehicles in the world for Caterpillar. What we needed to be able to support that was, and equally as first class as our product is in command for hauling, is a facility to be able to train our maintenance technicians to be able to properly support the autonomous haulage in Western Australia. So the issue is compounded in the fact that the equipment we play with and in the areas we play, you're talking about a lot of money and a lot of resource to be able to put people on site for training. Pulling these haul trucks out of a production cycle when some of these trucks are hauling sort of 240 tonne and might be doing a cycle every 15, 20 minutes. If you take iron ore prices at $120 a tonne, you start clocking up a few dollars pretty quickly. So one of the key areas that we needed was a controlled, safe and effective environment to be able to train our maintenance technicians. And not only WesTrac technicians, we also train our clients' technicians as well. So that really led to WesTrac making a significant capital investment in the Collie facility in January this year. So we started construction at the end of January. And if you can go to the next slide for me, please, Rita. We started construction in January and we did the official opening in June, which is the video you just saw. So it was a project that was partially funded through the Royalties for Region projects and the funding from the Collie's Future Development Fund. So we had a lot of buy-in from the West Australian government. We partnered with a good customer of WesTrac being Peace and Teeny and Sons Earth Moving, who operate a lot down in the southwest. And as the three of us, we constructed the facility in a very short period of time. So kudos to all involved in the construction of it. The interesting thing with the construction is that it doesn't, with an autonomous vehicle in a mining type environment, it doesn't matter whether it's 1 truck or 50 trucks and the associated equipment, you still need the same amount of infrastructure and rigor around the support of the facility. So whilst at the moment we have 1 789 dump truck and 1 what we call site-aware Hilux light vehicle in the area, we're hoping to expand on that shortly. So we're in the current process of upskilling a lot of WestTrac employees, getting them up to the standard we're looking for from a maintenance application. We're currently in talks with a number of parties on what we may be able to do down at the Collie facility in the future. If you're able to flick to the next slide, thanks, Rita. So we have got a lot of interest in the facility. The Collie is a coal mining town by nature. It's very accessible to most people in Western Australia as well. We're using it to showcase Collie. There is quite a significant history of coal mining there that is in the process of winding down. So we're actively and with the state government working towards trying to put more jobs into Collie, trying to support the locals in Collie where we can. And it's been very well received by all of the locals down there, which is really refreshing to see. If we can flick to the next slide. So one of the things ongoing as of this week is that we have a new Caterpillar drill undergoing some testing with Rio Tinto autonomous drill solution. So it's a non-CAT solution that is being installed onto a CAT product, and we're helping to be able to facilitate the phase 1 and 2 of its testing down in Collie. So we have 13 hectares down there available to use for various applications, depending what it is. We've got about 10 hectares of that covered by a site Wi-Fi network. And we have set the site up in a very contained solution. So just to prevent any cybersecurity issues, it is very much locked down. If you can head to the next slide, please, Rita. Future opportunities. So we do have a lot of Caterpillar Command products coming in. So we have Command for dozing, Command for drilling, and Command for underground, all relevant for Western Australia at the moment and being installed on client sites. We are actively pursuing other autonomous equipment, whether it's in the construction-related avenues or light vehicle side of things. It's an ongoing discussion about how to and when to within WestTrac. We are delivering now, and we're creating specific training for specific industry groups. We're working with the Mines Department in Western Australia about introduction to autonomous courses. We are now tailoring courses to our clients' need to be able to provide sort of a full rounded autonomous solution to help, whether it's a mining company and you want your mine planners and supervisors trained, or it's your workshop technicians. The idea is that we will have the facilities that are fit for purpose to be able to use. And we'd also like to expand on the non-CAT side of things. So while we're a CAT dealer, we also acknowledge that there is a lot of other products on the market at the moment that require support and potential integration into our current equipment fleet as well. And we'd like to continue building on our facility at Collie. We think there's great scope at Collie. There is plenty more land down there available for use, and there is a strong appetite in the local community to be able to support this sort of autonomous growth and innovation growth in Collie. So sort of a win-win all round for the town down there. If we go to the next slide. And that's basically it from a WestTrac point of view.
Thanks very much, David, and thank you, everyone. We are running a little bit behind schedule, but I do have some questions, and I think I might pose the one question to all of you. And David and Alex really showing the regional areas don't get missed out in these sorts of technology. That's an issue, but you know how we can build through the whole ecosystem of training and development and certification. So that's a great example of that. So just question to Tam and Majid in relation to scaling of the connected technology. It's a more mature technology than the autonomous technology. So some insights maybe that you've got from your test facilities around where's the scale likely to come and who's likely to pay for it. Maybe Professor, maybe home to you with all your partners and the insights that you gain.
Yeah, sure. That's a very good question, Rita. I think when it comes to technology and what is available for scaling up, I think it's still there are a lot of unknown that we need to go through. Just to give you one example, recently there have been lots of discussion about cameras and image processing. Every state is interested in them, and then they're coming with this, as they call it, edge for computing or edge computing. Which is good, but the question is, if you put thousands of them out, 500 of them out, what does it mean? And then, as you alluded to it, how this going to support connectivity and automation down the track. So I reckon is very difficult question to answer. What I could say is that the best place to have, again, places that you can get a sort of reasonable understanding of the challenges, and also the way that you can harmonize the rest of your technologies or roadmap of technologies that's going to come together, because otherwise it would be very difficult to build a foundation without knowing how many story building you're going to put on the top of it. And I think pretty much this is a challenge every city trying to address. We're building foundation without knowing, what is come to sit on the top of it. And I think unless you start, trying some of these technologies and look at, how to make them flexible for future is going to be always a big challenge.
Yeah, I think from my perspective, we're very interested in a more multimodal approach to what we're doing. So as I alluded to with our connected level crossings, there was also something I was reading last week regarding an EU declaration about CITS capability for trains from mid-2021. So transport's got very much an integrated focus at the moment in lots of aspects, particularly I'm seeing that as having potential for our trial. I'm also mindful that there's a lot of data floating around out there. There's a lot of great work getting done by some heavy vehicle operators and having systems that improve safety for their drivers. And I think from my perspective, looking at efficiencies, I'm very interested in learning how I can tap into that data, obviously having a strong governance background and what we're going to use that data for that data to provide us with some more richer insights of how connected vehicles, particularly heavy vehicles, the benefits they're going to provide. So rather than reinventing the wheel, so to speak, and kitting out lots of heavy vehicles with additional kit, which may not be productive for drivers or may be a distraction, I'm very interested in learning how I can tap into that. So we're in some stage with that. But I think moving forward, our focus is going to continue to be on heavy vehicles. The heavy vehicle task in New South Wales is huge, and like all states, it's going to grow. And we're very interested in tapping more into that and learning, how we can make that whole end-to-end journey not only safe but attractive for heavy vehicle operators as well, to get them to engage.
Thanks very much for that, and thanks for your insights. Now moving to our off-road facilities, maybe a question to both David and Alex. We've got a question from Tony Dong, just regarding simulation and where simulation fits into test facilities. We see a lot of the international test bed operations having simulation and also physical testing. Is that something that's on a roadmap in your facility, or do you see that? Oh, yeah. So Alex, maybe to you. So you're on mute. Sorry, Alex.
Sorry. Okay, so there you go. I was just saying, in terms of simulation, what we do here most of the time is dynamic testing. So say we're crashing a car into another car, into a product. It's dynamic. There have been instances where it was just more feasible to do a simulation study first before doing any dynamic testing, but I don't think you can truly replace what we do here with just simulation. It's always a good starting point to get your parameters and the basics right before spending a lot of time and money in doing destructive testing. But we don't focus heavily on simulation, but we partner up with various universities and other institutions who will do the simulation. We work closely with them, and then we'll bring that all together and apply that simulation into real-world applications as such. So I don't know if that answers the question, but we do have involvement in simulation, but we don't do that here generally ourselves.
And from a mining point of view, or from a Western point of view, we've been using simulators in mining, especially in WA, for well over 10 years now. So it's a very common practice for us, and we're just looking at engaging in a VR world as well at the moment for our colleague facility. So being able to literally pull apart a truck in a virtual world, to be able to help our maintainers understand the layout or the autonomous layout on what used to be a manned truck. So yeah, we use it a lot, and it will just grow more. It never quite beats the real thing as far as seeing and touching the real thing. However, it's a great segue for learners to come through, and a good revision tool as well. We find that you can do follow-up training 12 months, 2 years after the event, just to brush up on skills.
Great, thank you for that. Now I've got one last question, then I will let you go because I know you're all very busy. But the question here, and that's the purpose of why ADVI brought you all together, apart from to show the expertise that's available in Australia, but also to understand, you know, what do you personally feel that, what do you see as barriers to the accreditation of autonomous systems? Is it around having, well, I don't think it's about having the right test facilities, because I think we've demonstrated that we have got that, but what do you see from your experience around barriers around accreditation or national accreditation for Australia for autonomous systems? Maybe starting with Tam first, and then we'll move Majid, Alex and David, and then we'll conclude.
Oh, look, I think that everything we should be doing should have a national focus. I think harmonisation is incredibly important. We all need to be on the same page using the vernacular. Because the analogy I was using for someone the other day is the last thing you want to do is drive a car from Sydney to Tweed Heads and the vehicle stops for some reason because it goes overboard into Queensland or vice versa. So I'm seeing that a harmonised approach to this whole process is, to me, is really important.
Yeah, I think I agree with what Tam said, and I think we are not alone. You know, every other countries, you know, except few big one like USA or probably, you know, Germany, Japan, Korea, they probably have the same issue as we have here. And I think the only way we can get around it is, as Tam mentioned, we have a national approach. We consider, you know, all the state working together. I mean, everybody does some great work, but I think we need a bit more sort of, you know, probably, I mean, I would say we would need a bit more national coordination coming from the federal government. That would definitely help to get things together.
Thanks. Alex?
Yeah, I think Tam and Majid pretty much on the same page as what I was going to say. There is a lot of work in the background that's happening at the moment, trying to align all this. Tam, you'd be familiar being part of transport as I am. But as far as a crash lab and I'm concerned, we still need to make sure that we focus on safety assurance, which is a big part of what we do here. So it's all well and good to have everything in line at national and global, but the safety assurance is always going to be a very big part of that because it ties in together all your legislations, regulations, insurance. These are all very common challenges that everybody's facing across the world. But if we can really get a good grip on the safety assurance side of things, it would definitely be very useful to help establish these systems. So that's the way I see it.
So David, just drawing on the fact that we've had autonomous haul trucks in Western Australia and Australia for 10 years, and you know, how's sort of that accreditation? Is it safety assurance? Is it general sort of protocols that exist, and where do you see that maybe translating into other vehicles?
Yeah, so I suppose for us, where we live in sort of what I'd call a closed loop sort of world where we don't interact with the public, which at the moment, I suppose there'll be some stage that autonomous will grow to. At the moment, it's regulated. There's some harmonisation coming our way, which I think will be good. It's on a risk-based approach and really relies on the individuals or the groups understanding their risk and controlling that risk well, which I think is done incredibly well in Western Australia for the autonomous solutions, just through virtue of the importance of the system. And we've had our issues in WA mining in the past, where autonomous is helping to solve. I think anything other than a real solid approach at it is going backwards. So yeah, I think we're in a good space. As I said, we're very much simplified for the fact that we don't interact with the public. And I think internally within that, we control it well.
Thank you. And thank you all very much for sharing insights into your facilities. Thanks for sharing your morning and afternoon with us. To those online, we've got some questions. We'll post them to our experts and get them back to you. We've got a number of presentations coming up, another one tomorrow with Professor Nick Reed from the UK. And next week, we've got a webinar on universal design and how we develop vehicles to service those people that are marginalised from using vehicles now. We've also got a number of networking events. Yes, for those, sorry, Margaret. Some people can actually go to events together, but we do have a number of events coming up in Western Australia, South Australia, New South Wales and Queensland. So please stay tuned to that. Thanks very much, everyone, and enjoy the rest of your day. Thank you.
Thank you.